Right, so in this chapter, we're going to look at two main ideas, the scientific revolution and the Enlightenment. We're going to start with the scientific revolution, which started around the mid 1500s and went through the 1700s, and it's going to change the way we view astronomy, the universe, the way we view medicine and chemistry, even the way we think we learn and the way we develop. It's really going to change everything. It's going to challenge a lot of beliefs that and ideas that we Europeans had held for centuries, right? And so, why does it start when it started? Why didn't it start earlier? Well, we didn't have all the ingredients. Remember, we started to discover a lot of lost knowledge during the Renaissance, and not just lost knowledge either. Europeans began to study knowledge of the Arabic world. While the Europeans were going through the Dark Ages and medieval era, the Arabic world was having its golden age of astronomy and mathematics. And finally, the Europeans, or at least some of them, were willing to learn from this Islamic scholarship, and it was leading them to question things that they had held as true for centuries. And then you had the Reformation. Remember, that's when Martin Luther questioned the Catholic Church and questioned religion. And there's this idea that begins to float about, well, if we can question religion, we can question anything. We can question what we know. We can question why we think what we know is correct, because maybe it is not correct, right? Then you had new instruments available that's going to allow us to test new ideas and make new discoveries, things like the microscope, the telescope, right? That's going to help us and challenge, once again, our view of reality in the universe. Also, mathematics is advancing mainly because the Europeans were borrowing from the Islamic world and then adding to it. Eventually, things like calculus will be developed. More advanced geometry and algebra will be developed that will help us to figure out how the universe functions. We're going to start to figure out that the language of the universe is mathematics, and you can explain reality through math. And then the printing press is going to allow these new ideas, once they're developed, to spread quickly. And it's going to be easier for scientists and the scientific community to argue with each other and debate with each other and say, why don't you think this is right? Well, why don't you think this is right? Look at my discovery. Why don't you review my discovery to see if it's actually real? And it's going to allow these ideas to spread faster and faster and faster. So the scientific revolution really started off in the field of astronomy, right? The study of the heavens, right? And for centuries in Europe, there had been one model of the universe that dominated, the Ptolemaic system. Now, this system, the Ptolemaic system, said the Earth was the center of the universe, that it did not move, it was hanging out in the center of the universe, and all the planets plus the sun goes around the Earth, which makes sense when you stop and think about it, because we don't feel the Earth move. It looks like the sun moves. So this fit our senses. It also fit Yurt's belief system. The idea that the Earth, therefore humans, was the center of the universe made sense to them, because we are created in God's image. We are the height of God's creation. Of course, we are at the center of the universe. It seemed to fit Scripture. There's a scripture that said the foundations of the earth shall not be moved. So it fits the theology very nicely. And so beyond the suns and planets, it said that's where the fixed stars were, stars that did not move. And then beyond that, you get to the prime mover, right? What we Christians would call God. So this model of the universe actually gave a physical location for heaven, right? Once you made it past the fixed stars, bam, there you are. So this was nice and neat and tidy, and it fit our senses, it fit our theological viewpoint at the time. This is called a geocentric model of the universe, Earth-centered, geocentric, right? It also said that the heavens were perfect and unchanging, that once you moved past the orbit of the moon, you were in the quote-unquote heavens, and everything in the heavens was perfect and unchanging. Remember that. The Ptolemaic model said the heavens were perfect and unchanging. It also said that the planets and the stars were contained inside crystal spheres, one inside of another, which a lot of times modern people will make fun of, but remember, they didn't understand gravity yet. They had no concept of gravity yet. A crystal sphere idea is better than anything else. So this is what the universe would look like. So you got the Earth in the center, right? And each planet and the stars, right, have a crystal sphere, and these crystal spheres rotate. And once you get past the crystal spheres, you are in the realm of the prime mover, aka God. Right? So this had the support for centuries. This had the support of the scientific community and the religious community because it seemed to fit our senses and it seemed to fit our theology at the time. Right? So this gentleman here, Copernicus, right, he's going to start chipping away at that. Copernicus was a Catholic Church official who also studied astronomy. And by the time we get to the days of Copernicus, the Ptolemaic model, it was starting to have some problems. It was getting more and more complicated to try to explain away some of the problems in it. Like it looks like sometimes some of the planets move backwards through the heavens, which is kind of weird. And so they're like, well, that's because we have circles within circles within circles within circles, and the Earth isn't really in dead center. It's a little bit off-centered, so it's okay. It was getting a complicated mess. And Copernicus and many others were starting to think, surely there's a better system, something a little more elegant to explain the universe than the Ptolemaic system. And Copernicus, using observations that he made and observations of others that they made with their naked eye because the telescope had not been invented yet, using some newer math that had been made available during the Reformation, through observation, through mathematics, Copernicus was beginning to develop an idea that the Earth was not the center, but the sun was the center. Right? And he eventually writes these ideas down in a book called On the Revolution of the Heavenly Spheres. And in this book, he proposed a sun-centered, heliocentric view of the universe. Now, this was a pretty radical idea at the time. Remember, this is a time period where you could still be executed for heresy, false doctrine, for speaking out against the church. Actually, when he wrote On the Revolution of the Heavenly Spheres, he didn't publish it right away, probably out of fear, right? But members of his community, the astronomical community, right, had heard of his theories, right? One of his fellow astronomers pressured him to finally publish it. In fact, he never really published it until near the end of his life. In fact, the story goes that Copernicus was on his deathbed, right? And the first copy, the first printed edition of his book was rushed to him, and he held it in his hands and shortly after passed away, which is kind of interesting. So he kind of left this scientific bomb behind, and he wasn't there to deal with the consequences. Right? Now, most people that read this book, though, didn't understand it. It's a very complicated, dense book full of mathematics outside of a select few. Most could not understand it. So it didn't exactly send shockwaves throughout Europe. Only within a select community did it send shockwaves, right? People that could actually understand it. And even some of the people that understood it didn't think he was right. Martin Luther didn't think he was right, for instance. The Catholic Church didn't think he was right. The Pope didn't think he was right. So there were a lot of people who didn't think he was right because the idea that the Earth is hurtling through space seems weird because we don't feel it moving. And he did get some things wrong. He said that the planets move in a perfect circle, and they don't move in a perfect circle. More about that later. And he kept the whole crystal spheres thing. So he didn't get everything right. But think of it like he planted the seed of doubt, and others are going to come along, right, and add to his theory. Other people will come along, add his theory that will be able to explain it a little bit better than he could without all the dense math, right?